At first glance, it sounds like a simple update, a new name, a refreshed design, another version of the Tesla Semi, but the word Atlas changes the meaning completely. Atlas is not about speed or style. It is about load, endurance, and scale. This is Tesla signaling that the Semi is moving from limited pilot fleets into a machine designed for real, nonstop industrial work. When Tesla quietly allows a name like Atlas to surface, it usually means the product has crossed an internal threshold. Testing is no longer the priority. Deployment is. The original Semi proved that electric trucking was possible. Atlas is about proving it is economically unavoidable. Early information points to a larger frontal structure, reinforced frame geometry, and improved thermal systems designed for sustained heavy hauling. Not short demonstration runs. This is not a cosmetic refresh. It is a durability statement. Under Elon Musk, Tesla rarely upgrades designs unless manufacturing data demands it. That means Atlas likely reflects lessons learned from real freight routes, real drivers, and real payload stress. Before we go deeper, if you want structured, no hype breakdowns that focus on what actually changes and why it matters, please subscribe my channel so you do not miss the next part. In the next part, we will break down the physical design changes and what they tell us about how Tesla expects this truck to be used. The physical design upgrade. What changed and why it matters. The biggest clue that Atlas is a serious upgrade is not the name itself. It is the shape. Early sightings, manufacturing indicators, and design cues all point to a wider stance, reinforced front geometry, and a noticeably more muscular overall profile compared to the original Semi. This is not accidental styling. In heavy transportation, shape follows function, and function follows data. This shift tells us something important about Tesla's priorities. Tesla is no longer optimizing the Semi primarily for demonstration efficiency or controlled pilot programs. Instead, Atlas appears engineered for continuous heavy load duty cycles, the kind that define real commercial freight operations. With the Atlas upgrade, the front structure looks redesigned to tolerate higher sustained axle loads while distributing stress more evenly across the chassis during long-haul routes. This matters because freight companies do not judge trucks by short test runs or ideal conditions. They judge them by how they perform day after day, under load, across varying terrain, weather, and schedules. Structural fatigue is one of the most expensive hidden costs in trucking. Reinforcing the front geometry reduces long-term frame stress, minimizes component wear, and extends operational lifespan. Atlas appears built with those exact pressures in mind. The cooling architecture offers another major clue. Atlas shows signs of larger intake pathways and revised airflow channels, suggesting more aggressive thermal management for motors, inverters, and battery packs under constant strain. In electric trucking, heat is the primary enemy of reliability. Sustained loads generate continuous thermal pressure, and without robust cooling, performance degrades long before components fail outright. By redesigning airflow at the body level, rather than relying solely on internal cooling upgrades, Tesla is signaling a shift toward true real-world duty cycles. This truck is not being optimized for limited pilot routes or ideal weather scenarios. It is being hardened for industrial use. This approach aligns with Tesla's broader manufacturing philosophy. Under Tesla, design changes do not happen for cosmetic reasons. They happen when manufacturing data proves a change is necessary. That means Atlas likely reflects thousands, possibly millions, of real freight miles worth of data collected from early Semi deployments. This is not theoretical modeling or simulation-driven optimism. It is iterative engineering based on measured stress, heat loads, and component behavior over time. The result is a vehicle that looks less experimental and more inevitable. Under the leadership style of Elon Musk, products are not frozen at launch. They are hardened through use. Weak points are identified, reinforced, and simplified. Complexity is reduced where it does not add value, and strength is added where failure is unacceptable. Atlas embodies that philosophy. Rather than chasing headlines, Tesla appears to be building a Semi that can quietly replace diesel in the environments where diesel has dominated for decades. The physical changes signal confidence, not experimentation. In the next part, these design upgrades open the door to deeper questions. What do they imply about payload capacity over time? How do they affect durability under continuous operation? And what do they reveal about Tesla's long-term strategy for electric trucking at scale? Those answers matter because Atlas is not just an upgraded semi. It is a statement about where electric freight is heading next. What Atlas signals about payload, durability, and Tesla's strategy? Design changes always point to intent. With Atlas, the intent is clear. Tesla is preparing the semi for maximum payload consistency, not occasional heavy runs. The reinforced frame geometry suggests higher tolerance for repeated full-load hauling. That matters because commercial fleets do not measure success in single trips. They measure it in millions of miles under load. Early indicators point toward improved weight distribution across axles, which reduces long-term wear on suspension components and lowers maintenance downtime. For fleet operators, that translates directly into money saved. Durability is the real upgrade here. Atlas appears engineered for tighter manufacturing tolerances, simpler service access, and components designed to be replaced faster without extended downtime. That is exactly what large logistics operators demand. This also reveals Tesla's broader strategy. Under Tesla, consumer products often lead first. Industrial products follow only when economics are undeniable. Atlas suggests Tesla believes electric trucking has crossed that line, not future promise. Present advantage. And under the leadership approach of Elon Musk, once a product proves itself at scale, it gets reinforced, simplified, and pushed harder. That is what Atlas represents. Before we continue, if you want calm, structured analysis that focuses on real-world use rather than speculation, please subscribe my channel so you do not miss the next part. In the next part, we will look at what Atlas could mean for fleet adoption timelines and how quickly this version might replace earlier semi-builds, what Atlas means for fleet adoption and replacement timing. When a heavy vehicle receives a structural redesign, it is rarely meant to coexist long-term with the previous version. Atlas signals transition, not addition. For fleet operators, consistency matters more than variety. Running multiple versions of the same truck increases training costs, parts, inventory, and maintenance complexity. That is why this upgrade matters. Atlas appears designed to become the standard semi, not a special variant. Once production stabilizes, fleets will prefer one hardened platform that can handle every route, every load class, and every climate condition without exceptions. This suggests something important about timing. Early semi units were proof of concept at scale. Atlas looks like the version built for multi-year fleet contracts. That usually means two things happen quickly. First, new fleet orders shift almost entirely to the upgraded design. Second, earlier semi-builds gradually phase out of new production and remain in service until replacement cycles begin. Under Tesla, this pattern has already played out with consumer vehicles. Once manufacturing data confirms a stronger configuration, Tesla does not split focus. It consolidates. From a strategy standpoint, Atlas likely accelerates adoption. Fleet operators who were waiting for a more durable, long-haul ready configuration now have a clearer signal that Tesla is committing fully to electric freight at industrial scale, and under the operational mindset of Elon Musk, commitment usually precedes rapid expansion. If this breakdown helps you understand where Tesla's trucking strategy is heading, please subscribe my channel so you do not miss the final part, where we will discuss what Atlas could change for freight economics and why this version matters beyond Tesla itself. Finally, Atlas is not just a stronger truck. It is an economic signal. Freight companies make decisions based on cost per mile, not brand loyalty. And Atlas directly targets the three biggest expenses in trucking: fuel, maintenance, downtime. By reinforcing the semi for continuous heavy-duty use, Tesla is addressing the concern fleet operators have raised from day one: long-term durability under real freight conditions. Atlas suggests lower mechanical wear, fewer service interruptions, and more predictable performance across long routes. That combination matters more than headline specifications. When downtime drops, revenue rises. When maintenance becomes predictable, planning improves. And when energy costs stabilize, margins stop eroding. This is why Atlas matters beyond Tesla. Once one manufacturer proves that electric trucking can outperform diesel on total operating cost, the entire industry is forced to respond. Atlas pressures competitors. It pressures fuel suppliers, and it pressures logistics companies still delaying electrification. Under Tesla, industrial products are not released to test markets. They are released when internal data supports scale, and under the leadership approach of Elon Musk, once scale begins, it accelerates quickly. Atlas looks like that moment. If this breakdown helped you understand why this upgrade matters not just for Tesla, but for the future of freight itself, please subscribe my channel to stay informed as real-world deployment data begins to emerge. Thank you for watching. I will see you in the next one.